So then also here, there's a chart of how men rank women on the dating app versus how women rank men. And they're clearly, pretty different.
And to me, this chart says it all. Look at how men rate women versus how women rate men. And so men, they rate women accurately. It's on a bell curve with some people being ugly or unattractive and some being extremely beautiful, good looking, extremely attractive. But women, on the other hand, they view men differently. It's a skew chart. Most men, ugly, and hardly anyone attractive. Does that make sense? Think of it. It's supposed to be a bell curve. You can't have 80% of the people being ugly. The world is a bell curve. You can't have 80% in the shitter and only 20% that look good.
Unfortunately, I have some bad news for Greg. As it turns out, not everything is actually a bell curve. I want to ask you guys first to do a thought experiment, okay? Try to imagine that you have never heard of a normal distribution before. Do you think that this is something you would deduce from observing the world around you normally? That everyone kind of fell in the middle? Think about this specifically. Do people tend to fall in the middle of what they believe regularly? An implication here would be, if that were the case, that there would be very, very little consensus on anything at all. If you want to, pause the video, think about it, or not. Just keep following along. We tend to assume that things are normal distributions a lot, because it's a very popular concept. It's also one of the first concepts that we're taught in statistics, the normal distribution, right? So, for one, we observe normal distributions in nature, right? And in statistics when we're working with them, often. At least we do when the data is continuous. And typically when we're using parametric statistics, the kind of statistics we all learn at first, we're working with normal distributions. We're assuming normal distributions, right? On top of that, we create normal distributions when there are none as just a part of very, very basic parametric statistics, right? We rely on them for these kind of statistics for things like t-tests, right? And we basically force their existence even when the actual population does not have a normal distribution in, real life. So we'll get into that in a little bit. I'll explain that a little bit more. The point here, going through all of this, that I want you to take home is there is no cosmic law that says all things must be normally distributed. Unlike what Greg said, the world is not actually a bell curve. Some things actually fall on that distribution, but many, many things don't. And many of those things are, in fact, physical human traits. I'm going to give you a lot of examples and further explanation as we move forward here. First, I think something we should look at is Likert scales, right? If you don't know what a Likert scale is, this is your typical 1 through 7, 1 through 5, ordinal discrete scale where you're saying, rate this person on a scale of 1 to 10, rate this person on a scale of 1 to 5, on 1 to 7. Sometimes it won't be numbers. Usually, strictly speaking, a Likert scale is going to ask for something like, rate this person very unattractive, attractive, slightly attractive, and then they're going to say average, and they're going to say, very unattractive, and so forth. So really, Likert scales, when you get responses on that, you should expect not to get a normal distribution. Really, you should expect that they're not going to be normal distributions. Why? For one, Likert scales are bounded, right? That means if your maximum on this scale is a 10, you can't answer over a 10. And if it's a 1, you can't answer under a 1. This isn't the case with continuous variables, something like height, for example, right? Because height, in theory, could go anywhere from 0 to infinity, right? It's a number, so continuous there, and it can be anywhere in between. You can continue to break it down. These are discrete, so you can't get in between. If your scale is 7, right? You're asking 7-point Likert scale, and you have very unattractive and unattractive. You can't answer between very unattractive and unattractive. You have to pick between the two. So it is discrete and it is ordinal. And when you have scales like this, most of the time, you will not get a normal distribution. This is very important when we look at things like the OKCupid data being referenced in his original video clip, because this is the most common type of scale used when assessing ratings of physical attractiveness. Almost everything is some variation of a Likert scale. No one is asking for continuous variables on these scales. No one is saying, and I say no one, I think it has been done, but it's very, very rare. No one is saying, okay, just write down a number anywhere from 0 to infinity of how attractive you find a person, and you can use fractions as well and decimal points. It's just not being done. You get a forced choice, okay? So, another thought experiment here related to Likert scales. I kind of want you guys to grasp these concepts really well and think through them, because I don't mean to single Greg out here on this video, but what he said in these clips is something I've seen in comments, I've seen in discussions, and it's one of the reasons I actually wrote an article about this topic, because I've seen so many people refer to this OKCupid data, and they have said, basically women must be wrong, right? Because it has to be normally distributed, because everything has a bell curve, exactly what Greg said. So I'm using him as an example, but not trying to single him out here. What he said is not a novel belief. It's an incorrect belief, but certainly not novel by any account. And it's a very, very easy misconception or mistake to make as well. So, no shade on anyone here. Imagine, now, going to the slide, if you will, a question where most people answer strongly agree or strongly disagree. You can pause it if you want to, and maybe think through it. Is there anything that you think exists where most people would say, I strongly agree with this, or I strongly disagree with this? What about if you asked the question, I like to eat trash? Most people are probably going to say they strongly disagree. Not a favorite meal choice of most people, garbage. I like being burned with candle wax, Most people don't like to feel pain. They will rate that very, very low. Or a ethical question, something like, I think it's good to cheat on your spouse. Most people are going to say, no. Cheating on your spouse is actually bad. And so there's many questions that you can ask on a Likert scale where you are not going to get a normal distribution. Here is another question to think of, a bonus question. So if I asked you, do you think it's good to cheat on your spouse? Maybe you would like to answer. Could you answer something even lower than strongly disagree? Maybe not just strongly disagree, but I really, really hate it, right? Of course, given the scale, you could not. And why is that, right? Because it's bounded. That's the lowest score you can give. And what happens with bounded scales? People cluster at one end or the other, right? They want to give the lowest score they can, and that's the lowest. Or they want to give the highest score that they can, and that's the highest. And that's where you're stuck. And so you get what's called ceiling effects for the highest, and you get what's called floor effects for the lowest. And that's something to consider when looking at any kind of scale that is bounded in this fashion. Here is an example from a Likert scale on a survey that I recently ran, okay? This is on the website. It's the most recent article, datepsychology.com, guys. An example from a Likert scale of non-normality. Another way, aside from just ceiling and floor effects that these things kind of manifest, I asked people to rate the facial attractiveness of this one photo, which you will no doubt recognize, right? The very, very famous Giga Chad, the most handsome man in the world, according to some people. You can see the distribution here for men and for women. Most women rated him as unattractive. Most men rated him as attractive. But look at the way this distribution is. It's not a normal distribution. What we see here is that the responses were actually pretty polarized, right? Some people thought he was pretty attractive. Some people thought he was pretty unattractive. Not a lot of people said that's an average face. Makes sense, doesn't it? Because it's not an average face. You might like it, you might hate it, but you're probably not going to say, this face is of average attractiveness. So you can get Likert scale responses, even absent those ceiling and floor effects, that also are not normally distributed, right? This is kind of a bimodal distribution of some sort, I think. There's another problem with the interpretation of this OKCupid data, I think, that contributes to the mistake that people make. So this data was originally placed on a scale of 1 to 5. And women, the average rating was about a 2. So people say, well, if this was normally distributed, the average rating should be a 3. But the average rating is determined by your responses. It's not determined by what you put on a scale ahead of collecting those responses. Imagine again, try to kind of think through this. You ask people to rate the height of others, right? This is something that is known, that you actually measure independently of something like an attractiveness rating. So people can actually be right or wrong on this. You ask people to rate heights of, 10 men or whatever. And you give them a scale, and the scale is 1 through 100 meters. And people are accurate on these ratings. So you get an average rating of 1.77, which is in fact the average height of men. Then you plot it on a scale, like I have done here in very, very bad handwriting. And you see that you have this little curve over here at 177. And then it drops off and you say, oh no, height is not normally distributed because the median, the midpoint on my scale is 50. If it were normally distributed, it should be around that 50. Okay, intuitively, I hope this makes sense, because even though height actually does follow a pretty good normal distribution, if you select a midpoint somewhere else, it might not fall on that midpoint, and the midpoint of the scale that you select does not determine if the distribution is normal or not. What is the normal distribution? It describes the shape of the distribution, not really where it falls on your scale. If you went back and plotted averageness for this now on the slide, this is the same OKCupid data referenced. This is from Christian Rudder's book, Dataclism, who was, I believe, one of the founders of OKCupid or something like that. So we see the same kind of thing, right? Men rated women in a more uniform distribution. Note that the male distribution is not a true normal distribution. Okay, neither is the female ratings of men. However, it is more skewed. Most ratings in nature, most distributions, at the very least many, are not actually going to follow true normal distributions. So we see that men are closer to a normal distribution, but they still have a little bit of a skew, and women as well have a little bit more of a skew. The distributions that we see here are not especially skewed, okay? This is perhaps not as skewed as it could be. We do see, interestingly in this, that the attractiveness perceptions overall are different, which I think is a much more interesting finding. And if, like I said, I have an article on this. If you look to it, you might, I go into this more in depth. I'm not going to go into the video. But there probably are sex differences in attractiveness between men and women, right? Very possibly women are genuinely more attractive than men, and that's kind of what this data shows. But the skewness of the data is perhaps less important. We should also mention here the central limit theorem, right? So without going into a lot of detail on this, the central limit theorem lets us take samples from the population and create normal distributions when there really is not a normal distribution, okay? And the larger the sample you have, the more it will approximate a normal distribution, even if your actual population is not normal. So we can see here from this article by Kristen Sanani, I think, you have a small sample from a non-normal population, and you can see that that small sample is skewed, which is probably going to be reflective of the population, which is also non-normal. You increase that sample size to 30 and already, or to 10, and you see, boom, a lot of that skewness disappears. You increase it to 30 and already you get a very, very good normal distribution, okay? 30 people is about the beginning point of where you expect the central limit theorem to hold. That's when you can begin to apply parametric statistics and make certain assumptions about it. So even knowing that the population that this came from is not normal, we can take this sample and make an assumption. And this is one of the reasons I think that people begin to assume that normality exists in nature all around us, kind of like a cosmic law. But as I mentioned, it's not a cosmic law. And the actual distributions of populations, of course, we can't know what they are in all cases. In some cases we can, and this depends on, of course, things like the size of the population. In some cases, maybe we really have access to the whole population. In most, we probably don't. But in many cases, right, it's not going to be normally distributed. We can find, nonetheless, from samples of things, that there are even large samples that still show non-normality. Many, many examples of non-normal distributions in real life, right? The world is a bell curve. It's not. It's not a bell curve, guys. It isn't, okay? We can see it in behavioral data a lot. Drug, alcohol, and coffee use from that same article. There's a couple of small examples. They are going to skew toward 0. Why? Because most people are not consuming it. And the people that are consuming it may be consuming it a lot more, right? There might not be as much of moderation there. Or if you go to the very, very end, you may see, a little bit of moderation, perhaps in the case of something like coffee or alcohol, and then that goes down to, extreme use. School test scores are actually not normally distributed. Why is that? Well, you need 70% to pass a class. Conventionally, I'm not sure if that's still the case. But you can get anywhere from a 0 to a 100. So is half of the class failing all of the classes around the world? Not usually. Most of the time, most of the class passes. So in school test scores, for example, we can regularly see a non-normal distribution. The age of giving birth usually has a skew to it as well. Why is that? Well, most people aren't giving birth when they're 60, 70, 50, 40 years old, even when they're 30 years old, right? Most people are giving birth in this small window of age that comes a little bit earlier in life. Here's a couple of examples from an article by Pizdek, I believe it is pronounced. Bill payment. When people pay their bills, most people pay them pretty close to when it is due. Some people don't. Okay, another example of zinc. I think this is the zinc distribution in platings in metallurgy, right? The way that it comes out. So again, you see in kind of this natural engineering example of the way that this metal forms, also not normally distributed. So it's not just behaviorally, but also in nature, in physical non-human things, we regularly see non-normal distributions. You may be asking at this point, I guess another example really quick, I'll move on to this slide, is sexual partners in 2021, also from the website here, from the GSS 2021 data. Not a normal distribution, right? Very, very skewed distribution in this case. Most people not having a lot of sex. So you may be looking at these examples and you may still be thinking, okay, well, what about physical traits, right? Surely physical traits are normally distributed. People tend to think of common ones like height being normally distributed, which actually does seem to follow a very, very good bell curve. Many things don't in human physicality, in the animal world as well. I guess the most obvious of these would be sex, right? Male, female. It's going to be a bimodal or a binomial distribution, okay? The human lifespan itself, not a normal distribution. Most people don't die right in the middle, right? They die when they're old. You plot that on a graph. This is when they're dying, up here. Eye color, good one. Why eye color? Well, eye color is discrete. You either have one eye color or the other. We don't typically have mixed eye color, do we? Another example of one that follows a more continuous plot is sperm count. Here's Sedgwick 2010. Okay, sperm count tends to cluster. Most people don't have a really, really great deal of sperm count, but it's also not following a bell curve. I think probably a really big one here from Kostolsky and Gawilski is the size of the bodies of animals, right? That's one of the things probably I think many people would actually assume is normally distributed that isn't, okay? So there's a slight right skew here. So even body size doesn't have a perfect normal distribution. The number of fingers people have, and this is sometimes used as an example in statistics classes, I think people find it amusing or something, is that if you have 10 fingers, you actually have a number of fingers that is above average. Most people have a number of fingers that is above average because of the skewness of the distribution. Okay, why is that? Well, some people are born without fingers. Some people lose their fingers. So if you have 10 fingers, you're going to be slightly above average. Another big one, I think perhaps more intuitively here, something that might make more sense is skin tone, right? So this is pretty continuous. It's not quite as discrete. And this is something that we see that is skewed both within populations and at the global level, right? Skin tone isn't distributed normally. You go from population to population and you'll see either much lighter skin tone or people clustered up with much darker skin tones. And if you look at the global population, the same. You will see that some skin tones are, as you go up, the proportion of people with that skin tone tends to increase as well. And a big one here, probably this is one that Greg, being a fitness guru, I suppose, should have known about, which is, of course, body mass index, right? Body mass index, not a normal distribution, has that skew again to it, right? There's certainly more people with higher BMI, a larger tail on that higher end of the BMI than there is on people that have that very, very, very low BMI. Another question here, another point that we need to consider when we look at these ratings of attractiveness on a Likert scale. Even if that Likert scale takes an ordinal form of numbers, you think of the decile scale, he's a 1, he's a 10, rate these people 1 through 10. Okay, what does average, or what does the midpoint on a scale mean in that case? When you ask someone, it's probably the case that most people are not thinking in terms of an objective or a mathematical average, okay? They're probably not saying, a 5 or an average person means someone who I have obsessed objectively to mean someone who is in the midpoint of all human beings based on their features. What is more likely is when people respond this way, that they actually mean this is someone who is neither attractive nor unattractive. Particularly when you kind of prime and cue people with Likert scales, that would be the more natural interpretation as well. And why is that? Because you're asking someone, let's say it's a 7-point scale. You're saying very unattractive, unattractive, slightly unattractive, average, slightly attractive, attractive, very common form of this Likert scale. Average there is the midpoint between someone who is neither unattractive or slightly unattractive and someone who is slightly attractive. Okay, they're not asking where most people reside. They're asking you where, or responding, I should say, as to a person who they see as neither unattractive nor attractive. Someone who is in the middle. That's not a statement that they view that person to be representative of the majority, as in the actual middle of a bell curve. So that's something to consider, okay? Something else to consider is that what's being measured here is the rater's opinion, all right? We're not measuring the actual attractiveness of another person, at least not directly. It's important to understand that as a kind of interpretation of what we are going for, all right? Let's say we asked people to rate height. We asked someone to rate the height of 30 men, and they say, okay, this person is 1.5 meters. This person is 1.7 meters. You could take the average heights measured with a ruler, with a tape measure, and compare them with the rated heights, and you could say, they're wrong. You could say they were inaccurate by this amount. And we know because we have a ruler and we have a convention for what height means, and we can measure them. Not the case with ratings of attractiveness. Ratings of attractiveness are basically the measurement in and of themselves. And the thing that is being measured in most cases are the ratings, right? The rating is the measurement that is being reported. It's not the individuals. So something as well to consider. The important point here, the take-home point, right? With these measurements of, or I should say, with these ratings of attractiveness, unlike height, unlike something that has a ruler, there's no external measure that we can compare these to, right? Kind of what I just mentioned. There's no external measure. There's nothing that would let us know that someone is right or wrong. We are basing that on the rating. And in that sense, you kind of have to take the ratings at face value. You can't just look and say, oh, women are wrong because I want to assume that a bell curve exists. There's no reason to believe, a priori, that attractiveness falls on a bell curve. There are some reasons to believe that it really doesn't, right? That there's actually more unattractive people than attractive people. I'm not going to get into that here, but I do get into that a little bit in the article. So things to consider there. Probably this argument, like women are wrong because they don't rate everyone perfectly equally. Probably not the case. Let's do another thought experiment. I think maybe this will kind of additionally clarify things. Because some of these concepts are kind of not intuitive immediately. Imagine, guys, imagine this, if you will. A wizard. And he casts a spell upon the whole world, or at least upon all the men. He makes every man 90% less attractive than where he is now. Based on what I said about Likert scales, about bounded scales, and that sort of thing, how would you expect the distribution to change on a plot? And aside from the scales and the measurement, if a wizard cast a spell on 90% of men in all of the world, do you think those men would be equally desirable as before? For example, it shifts, all of the men, would a 5, having been reduced, be just as attractive as a 5 previously was? Would a 9, from whatever they were reduced from, be just as attractive as they previously were? So for the first question, you would probably, if it's a bound scale, you would just see a bunch of people cluster up. You would just have a ton of ones at that point, and then you might have a couple of 6s and a few 5s, but it would just be, boom, a massively skewed distribution. There's nothing, magically that would prevent that. So there's nothing conceptually to say, oh no, that's impossible. That's what it would look like if you had, a 10-point decile scale commonly used, or a Likert scale or something. Just boom, skewness clustered up at the end. And do you think that men would be equally attractive? This, it doesn't have a right or a wrong answer here. It's kind of, a thought experiment. It's something to think about for yourselves, because there is a point of view that says, attractiveness is kind of objective. It doesn't really matter as much on the context. If someone is ugly, they're ugly. And it doesn't matter if everyone else around them is ugly or not. You're just stuck with a bunch of ugly people. But there's another idea that says, attractiveness might be kind of referential. So if everyone is ugly, the most attractive ugly person is suddenly Chad. He's suddenly super attractive. I don't know. That doesn't sound like the way that it would play out to me. But like I said, there's not a wrong answer here. There's something to think about. Maybe leave a comment, guys. Let me know what you think about this. If all men in the world suddenly became 90% less attractive now, so you had a bunch more men who are genuinely unattractive, do you think that essentially women would view those men as 5s and stuff as they do now? I don't know. And so there's a question here, that people have discussed ad nauseum with this OKCupid data set and similar kind of findings out there, I suppose. And that's, do women really find most men to be unattractive? My answer at this point, it's kind of a maybe. There's some evidence for that. For example, the OKCupid data set. Okay, sure. So this is, evidence that indicates most women, if you ask them to rate men on a 1 to 5 scale, will rate most of those men as unattractive. Okay. I've seen a couple of people mention, well, maybe the OKCupid data set is oversampling unattractive men, which, is not an unreasonable assumption for online daters, right? You might think, okay, these are single men. They're online dating. All of the more attractive men are already in relationships, so they're less likely to be online, okay? Not an unreasonable hypothesis for what might be going on. At the same time, Christian Rudder, in his book Dataclysm, who, did all of the statistics with his data set, he ran a similar analysis for faces across Facebook. He took a bunch of random faces from Facebook, had people rate them, and had a similar effect. So, it wasn't just single men in this case. It seems to be the case that ratings of men are pretty low. Some evidence against this, okay, might be taken from actual behavior, actual mate selection. And I've discussed this in other videos a great deal. Most men, for example, they're in relationships, okay? 70% of men across age groups are in relationships. About 50% of men between 18 and 25 are in relationships. You go up to that 26 and above category, and that's when you start to see about 70% of men in relationships. You can also look at, for example, moving to the next slide here, there's a pretty large disconnect between what people report and what they actually pick in mating scenarios. I would recommend looking up Paul Eastwick. Look up his ResearchGate, and he has so many papers on this. I'm not even going to mention just a specific one, but a lot of his work has looked at this kind of disconnect between stated mate preferences and actual mate selection, who people are actually picking. And one of the things, that he found is about after 9 months, even physical attractiveness doesn't predict who is still in a relationship. So it could be the case that if you ask people to rate, like, oh yeah, everyone's ugly, but then, you ask them to pick and they're picking people, and that's just fine. Perhaps another piece of evidence that doesn't match up with this women find most men ugly thing is the actual dating app statistics as far as who meets off of the apps and who gets into relationships from apps doesn't even match up perfectly with the OKCupid ratings, okay? So 40% of Americans who are in relationships formed that relationship from an app. So apps are one of the major ways that people form relationships at this point. So only 20% of men on apps are supposedly rated attractive per the OKCupid dataset, and yet a much larger percentage is actually getting into relationships from the app. So are women picking men that they find unattractive? That would be perhaps a less charitable interpretation. Certainly I've heard people say that. There is kind of that maxim that people say, which is, watch what women do, don't watch what they say. And probably the best measure of what women do, and I think this is also used in methodology and psychology, not just about, dating, but about other things, is looking at actual behaviors and comparing them to self-reports, to stated preferences. And sometimes, as in the case of Paul Eastwick's research, we will see a disconnect between people's actual behavior and what they say. Similar research on dating apps has shown, about 50% of the people who use them actually get to meet people. I've mentioned a few papers in the other videos on that. You could go to the Pew Survey of Online Daters from 2019 for a representative sample of this. But most people, I didn't say most, about half of the people who use these apps seem to, have a little bit of success with them. Is that good or bad? I mean, maybe, half of people barely even getting a match. Kind of bleak, but at the same time, it's not quite as bleak as saying, 80% of people are completely discarded, because that doesn't seem to be the case either. Something important to consider from this, I'm going to refer back to these charts from the GigaChad survey here, okay? Even if most women find you unattractive, there's still a large cohort of women that might find you attractive. And you only need one woman to find you attractive. You don't even need most women to find you attractive. When we look at averages, these group averages, they may kind of obscure the way that women feel about individual men, right? They might kind of obscure that. And look at these two charts here, okay? So we have a couple of box plots. And imagine if I just reported just the averages of this. I would say women view GigaChad as unattractive. Actually, the title. So if that was all you saw, if that was all that you took from it, you might think, gosh, he has no chance. Women think he's ugly and that's it. And the implication there, the unsaid implication from that might be that no one likes him. But when you look at the actual distribution of ratings, you see, okay, women don't find him unattractive on average. But there's still a cohort of women, including some women, who rated him extremely attractive, right? They rated him highly attractive as you could on the scale. And if he were to want a relationship, he doesn't need the attention of that 60 or 70% of women who fell to the other end. He just needs one woman that finds him attractive, and that's it. So something to consider from this, even faces that might seem very attractive are not viewed as attractive by many women. And even faces that many women might rate as unattractive are still going to be viewed as attractive by some women. And that might actually help to reconcile some of what we see in data showing, that women rate most men as unattractive, and yet most men get into relationships. Because it's kind of normal if most women don't find you attractive, but some do. I think that's actually kind of the natural state for men in this case, is that maybe most people won't find you attractive, but some will. And you know, that's your pool there that you have to work from. And I think this is kind of true in the opposite direction. And I've heard men say otherwise, but I've also heard men say this. And this is kind of my perspective on it. If I walk down the street, or if I go someplace with many women in my age group, I don't find a majority of those women attractive. You know, I might find a handful of those women attractive. Some of them are, but that doesn't mean that the majority of women I find perhaps unattractive, that I would not prefer to date, aren't attractive to other men, okay? It doesn't make them unattractive or ugly women. And I'm sure that there are many, many men who feel the same way, who view the same pool of women, and they think, you know, maybe some of those women that Alexander likes, not really my cup of tea, but perhaps some of those women that he doesn't like as much, I do kind of find attractive. And when you get those overlapping differences in attractiveness, it kind of gives that dispersion, right, that actually supplies people with a mate every once in a while. And that's all you need, guys. You just need a girlfriend, you know, once in a while, so to speak. You don't need to meet a new woman or whatever every single day. You don't have to attract all of the women. You know, you want to attract one woman and have a relationship, ideally that lasts a very, very long time. Maybe that's not your goal. Maybe you want to be like a pickup artist or whatever and have a bunch of relationships. Personally, that's something that I would kind of say was my goal. You know, you have a relationship that's a good relationship and it lasts a long time, and be happy with that. So hopefully you guys learned some things. Hopefully the video was fun. Leave a comment, like, subscribe, and I will get back to you guys with another video very, very soon.